We have done the dehydration of alcohols, and I told you this is called beta elimination reaction. That is, the alcohol should have a beta hydrogen. From beta hydrogen, the hydrogen goes out. From beta carbon, the hydrogen goes out, and from alpha carbon, OH goes out totally. When you add it, then it becomes a molecule of water, then you get the alkene. Clear? But there are some compounds where beta hydrogen may not be there, but still the molecule loses a molecule of water, leading to the formation of alkenes. This I am doing not for your board, but for your entrance exam. Let us take this molecule. See here. What is the name of this molecule? 1, 2, 3. On second carbon, you have 2 methyl. So I'll write here 2, 2 dimethyl propan 1 or. See, this is alpha carbon. This is the beta carbon. So this beta carbon does not have any hydrogen. Clear? Then if there is no hydrogen, how OH will go? Okay? Okay. For your understanding, I write it here. See. No hydrogen here. No hydrogen here also. So if I treat this compound with concentrated H2SO4 at 443 Kelvin. So in that case, strange we find it forms an alcohol. All right. So first I'll write the mechanism, then I'll show you. And again I'm telling you, this is for your understanding. It may not come in your board exam. Okay, see here. We know that sulfuric acid dissociates to give us proton. Now, what is the molecule here? Molecule here is alcohol. This is the one, oxygen lone pair, and this is the proton. So you know very well, this is the donation of pair of electrons. So what we are going to get? We are going to get corresponding oxonium ion. Please remember, oxygen with trivalent oxygens are called oxonium ion. You will form this. Now you know that after that carbon oxygen bond will break. So once it breaks, what you will get? You are going to get here corresponding carbocation and water. Now see there. In earlier cases, what happened? Hydrogen was there. Hydrogen gave the electron to form a double bond. But here you do not have any hydrogen. In that case, what is going to happen? No problem. See, this is primary carbocation. Primary carbocations are less stable. So in that case, what is going to happen? This molecule immediately will rearrange to form a more stable carbocation. Okay, see here. From here, this methyl group with a whole bond means there are 2 electrons in the bond, both the electrons will migrate here. So what you are going to get? In that case, you find it is going to form C. The methyl has migrated. From where is migrated? From this carbon to this carbon. Okay, migrate that carbon, will say 1, and next carbon is 2. So we'll write here now 1,2 methyl shift. See, why did it migrate? Because it has formed more stable tertiary carbocation. All right? Everything in this world always goes for more stable state. So now what is going to happen? See, now in this, if this is alpha, then this is beta. Then this hydrogen will give the electron and you will get here CH3, CH3, H, and CH3 and H. So now I'm going to write that it will give me CH3, CH3, H plus water. My request, please write down. Please write. Don't keep it in the video. And write as fast as possible. Finished? Hello? Hello?
Yes, sir.
Okay. So I told you, no, whenever you finish, you please tell me. Okay. Now we go to the next category. This is the third category of reaction. Now we will go for the properties due to the cleavage of alpha carbon hydrogen and oxygen hydrogen bond. So means what? Lots of hydrogen molecule only. Now we are going for D. Properties due to the cleavage of alpha carbon hydrogen and oxygen hydrogen bond. Okay, that is, if I have taken here and alcohol. Okay. See, this is the alpha carbon. So this carbon hydrogen bond breaks and this oxygen hydrogen bond breaks. Means what? What goes out? Hydrogen molecule. So loss of hydrogen is nothing but oxidation. So we write that is oxidation reaction. Oxidation reaction. All right, this is important. So now, see, depending upon the type of alcohols, our oxidized product will be different. So we know that there are three types of alcohols. They are three types of alcohols are there. They are primary, secondary, and tertiary. So we will study three of them one by one. In your textbook, they have given the oxidation reaction of primary and secondary. Somehow, tertiary alcohol oxidation, they did not give. Then oxidation of primary alcohols. Okay. So I'll show you a scheme. Once you know the scheme, then you will know what type of products are possible, and we'll proceed accordingly. Okay. See here. Now, oxidation means loss of hydrogen or addition of oxygen. See dear, first this will go. So I'll write here now oxidation, and here I'm going to write here 2H minus C 2H. So what will happen? 2H and oxygen will react to give you what? Water. Now, what is going to happen? In that case, see, valency of carbon is 4. So 1, 2, 3, 4. When this bond goes, immediately there will be a bond between carbon and oxygen. So what we are going to get here? You will get here this. All right. So what is this? This
aldehyde.
Very good. Aldehyde. Okay. Now, again, if the oxidation occurs, then the oxygen will be added. But carbon valency cannot cross 4. So where it will add? It will add between carbon and hydrogen. See here. So what will be this? Oxygen and oxygen. What I write like this. See here, valency of carbon is also satisfied. Oxygen is also satisfied. So what is this one?
Carboxylic acid. Carboxylic.
But I cannot hear any female voice. Why you can? They are sleeping or what? Or none of the female has come. They are busy in cooking. See here. So when you carry out the oxidation of primary alcohols, we are supposed to get two types of compounds, aldehydes and carboxylic acids. Okay. Now, aldehydes are very easily get oxidized. So in that case, the ultimate product will be carboxylic acid. Clear? So now I can say, if you go for partial oxidation, the product is aldehyde. And if you go for complete oxidation, the product is carboxylic acids. Now see, in this molecule, whatever the product that we are getting it contains the same number of carbon atoms. Why I am mentioning same number of carbon atom? It has a purpose, because one will go for the oxidation of the secondary alcohol, you'll find this is sometimes does not happen. So you are going to get this. Now, if you wish to stop this reaction from aldehyde, that you can do it. So how can you do this one? In that case, we need not take very strong oxidizing agent. Some chromium 6 oxidizing agents are there. In that case, you find this reaction can be stopped at the aldehyde level. Or if you use strong oxidizing agents, in that case, you will not be able to separate aldehyde. The final product will be carboxylic acids. But one very interesting thing is that the boiling point of aldehydes are much lower than the boiling point of carboxylic acids. So by using strong oxidizing agents, if you wish to get the aldehyde, what you can do? So you can start this reaction in boiling condition. Moment the aldehyde will form, aldehyde will distill out. So the excess oxidizing agent cannot oxidize this aldehyde into carboxylic acid. That is our experimental technique. All right. So at this you need not know so much experimental technique. So what we are going to do? We are going to classify this oxidation of primary alcohols into two categories. One, oxidation to aldehyde. Second, oxidation to carboxylic acids. So let us go for oxidation to aldehydes. All right.
Yes, sir.
So we'll try to do this one. See here. A. Oxidation of primary alcohols to corresponding aldehydes can be achieved by using chromium 6, means what? Oxidation status of chromium is 6. Chromium 6 reagents in anhydrous solvents, means we are not using water. What is the solvent we use? Example, we use dichloromethane. Okay. Now what are the reagents? Reagents are pyridinium, chlorochromate. Okay, in short form we write PCC. But how does it looks like? That day I told you that pyridine is just like benzene. Okay, this is pyridine. Moment we say pyridinium means what? Here the nitrogen valency has become 4. So it is having H. So this is the cationic part. This is called pyridinium. Okay, and chlorochromate. So you'll find it is CrO3 Cl. This one we make it by reacting pyridine with CrO3, pyridinium chlorochromate. Clear? And this is being prepared by a very famous scientist from West Germany. Is called Core. E.J. Core. So it is known as Core's reagent. Okay, for entrance exam, they may give you Core's reagent. Second, we can use Dinium dichromate. Okay, in short form we call it PDC. So what is this? Dichromate valency is 2. So in that case, you'll find this will be twice Cr2O7. Okay. 3. We call it Collins reagent or Collins Serex reagent. In this case, what you do? We take chromium trioxide in purity. Then Jones oxidizing agent. Okay, this is chromium trioxide in concentrated H2SO4. See, in all the cases, the oxidation state of chromium is 4. So it is 6. 5. We can write here equimolar ratio of Na2Cr2O7 or K2Cr2O7 in concentrated H2SO4. So these are all the reagents can be used. Clear? Now, in such case, whenever we start the reaction, we'll do this first one, PCC. And we are not going to write the formula because you will not be able to remember also. So we are going to use the abbreviation. All right. So let me remove this one. And I'll write one general equation. Here I am going to write O. And I'll write here PCC. And here I'll write CH2Cl. And here I'm going to write. So this is our general equation. This equation is often asked in exam. Okay. Now I'll do specific reaction. See here. I'll take here ethanol and I will do that. I will add PCC in dichloromethane. So you go out. So I will get here acetaldehyde and water. So this is ethanol. I have to write the name because I know you are suffering from dementia. So every time you forget the name of the molecule. Of course, it's not your fault. It's fault of your age only. You are elder to me only. Ethanol, acetaldehyde. Similarly, see you get aromatically. I told you that in organic chemistry, the preparation of one compound, property of one compound is the preparation of other. So this one we are going to study again in preparation of aldehyde. Okay. So if I have taken here benzyl alcohol, in that case you will find this will give me benzaldehyde. Okay. Will give me benzaldehyde. See, one advantage of using PCC is that if I have taken an unsaturated molecule, in that case, PCC will only oxidize the alcohol group. It is not going to oxidize double bond. But if you use a strong oxidizing agent like potassium dichromate, you can use, if you use potassium permanganate, in that case, this molecule will oxidize not only the alcohol, it will also going to oxidize the double bond and break the molecule. This never happens in case of the PCC. That is the advantage. You will find this sentence is written in your textbook also. Okay. So let me take an example. Suppose I have taken here see, you know, this is called two carbons are called vinyl, this is called allyl. So this molecule is called allyl alcohol. Allyl alcohol. So this one, if I oxidize with PCC, in that case, you will find it will only this portion will oxidize, this will not be oxidized. So this type of reagents are called regioselective. That is, it is active in this region, it is not active in this region. So PCC is a regioselective, regioselective oxidation. So in that case, see here, you are going to get one. This type of compounds are called alpha, beta, unsaturated aldehyde. Okay, why do you call it alpha beta unsaturated aldehyde? Because the next carbon to functional group is called alpha. This is alpha carbon, this is beta carbon. So you have the double bond between alpha and beta. Okay, alpha. So alpha beta unsaturated aldehyde. Right, this is the class. And what is the name of this compound? This name of this compound is acrylaldehyde. IUPAC name is what? Is very easy. See, 1, 2, 3. You call it prop 2 in 1 or propinol. All right. So now we'll go for its complete oxidation. B. Complete oxidation. It is oxidation of primary alcohols by strong oxidizing agents such as CrO3, Na2Cr2O7, K2Cr2O7, and KMNO4 in H2SO4 or alkaline KMNO4 give corresponding carboxylic acids. Give corresponding carboxylic acids with same number of carbo. Yes. Same number of carbon atoms. So I'll write it here. General equation R C H H O H. Here I'll write 2O. One O will remove hydrogen, second O will be added. Okay, so let me write it here. K2Cr2O7 or KMnO4 and H2SO4. It will give you carboxylic acid plus water. Direct. You cannot isolate it now. Okay. Now, if I have done, instead of sulfuric acid, if I have added potassium hydroxide, so in that case, alkali. In that case, what you will get here? You, after the formation of carboxylic acid, you know, acid and base will react to give you salt. So in that case, you will get the corresponding salt. So you will get here salt. You will get this. Okay, suppose you cannot remember. No problem. So many things. How can you remember? You are such a small brain. Okay. See, what you get? You remember R coke. Okay. Then to that we add acid and neutralize, and we get here the carboxylic acid. That is, you will get oxidation by KMnO4. We get R cook, and after neutralization we get R cook. So cook and cook, to you remember. Otherwise, you practice at home. Okay, this is the one. So now I will do the specific molecules. So I'll write here now CH3. What is this? Ethanol. What is this? You'll get this. What is this? Acetic acid. Okay. Now, if I have taken benzyl alcohol, if I have taken here benzyl alcohol, okay, so here you are going to get so you get here benzoic acid. Okay, and if you have taken alkaline KMnO4, so what you will get now? Can you say? Hello? Huh?
Yes, sir.
Very good. See here, I write here 2O, and it is KMnO4, KOH. What you will get? I told you, no? Coke. So you write this. Okay? And then you write here cook. Then after this, what is the next step? Cook to what? I told you, no? How to remember? Cook and cook. What is cook? Carboxylic acid. See this. So please remember that if you oxidize primary alcohols, first it will give you aldehyde, and this aldehyde will go oxidized to carboxylic acid. Clear? So if you want to stop this reaction at carboxylic acid, we are going to use milder oxidizing agent like the dichromates and milder conditions. We will not go for boiling. So if you use PCC, you will find it will give us corresponding aldehydes, and this molecule will contain same number of carbon atoms as the alcohols. Okay, and if you use strong oxidizing agents on heating, then what you will get? In that case, you will find that on heating, you will find that if you use acidic medium, it will give you same carboxylic acid having same number of carbon atom. And if I use alkaline medium, in that case, it will first give you the potassium salt of carboxylic acid, and that it will neutralize. Any alkaline reaction has to be neutralized. Then you will get corresponding carboxylic acids. Okay, now we'll go for the oxidation of secondary alcohol. Secondary alcohols. Whatever thing I'm talking to you, do you really understand? Huh? Hello?
Yes.
Huh? Do you really?
Yeah.
Or you are just attending the classes as if you are attending some religious meeting? Huh? Whatever the priest is saying, most of the time, whether you go to church or temple or mosque, huh? Whatever the priest says, we close down your eyes and hear it. Huh? Half of the thing we hear and half of the thing we do not hear. So it is not a temple. Okay. Secondary alcohols. We'll write secondary alcohols on oxidation with secondary alcohols on oxidation with both mild and strong oxidizing agents give corresponding ketones with same number of carbon atoms. Okay. So now I'll write. Suppose I have taken this R1 C O H H R2. What happens now? See, this goes out. So I'll write now here oxygen. Okay. So you can use. Let us use a strong oxidizing agent, but we are not going to boil it. Say it is K2Cr2O7 or KMnO4 and concentrated H2O. So this will go out. So what you will get now? You will get R1COR. So what is this? This is a ketone. And this is secondary alcohol. See, ketones are not as sensitive as aldehydes to get immediately oxidized. So reaction will stop there. Even if you use a strong oxidizing agent also, it will not go beyond ketone. So let us write now. Suppose I have taken here this. See, what is this name? I told you second carbon OH, so it will be iso. How many carbons are there? 3. So it is called isopropyl alcohol. So what is the name of IUPAC name? 1, 2, 3. So I'll write here now. Propan to all. So suppose I've taken here KMNO4, H2SO4. I'm not adding heat. Okay. So what I will get now here? CH3, CO, CH3, and H2O. So you will get here now acetone. Okay, you will get acetone. So all secondary alcohols will give you corresponding acetone. So in your aldehyde ketone chapter, this will be the preparation of ketones. Please remember. Aldehydes can be prepared by the oxidation of primary alcohols by bind oxidizing agents, and ketones can be prepared by the oxidation of the secondary alcohols. Okay. Now, suppose you have carried out this oxidation with strong oxidizing agent under boiling condition. That is, you have taken potassium dichromate, you have taken KMNO4 in sulfuric acid, or you have taken concentrated nitric acid and you boiled it. Then in that case, what will happen here? This molecule will undergo, it will break down. And after breaking, it will get oxidized. So in that case, you are going to get mixture of carboxylic acids. All right. So anyway, again, this portion is missing in your textbook. I don't know who has written your textbook. Maybe he is a very kind person, maybe related to you as your grandfather or grandmother. Okay, but if I would have written it, I would have written complete. See here. Unlike aldehydes, ketones do not undergo further oxidation. However, under drastic condition, the molecules undergo oxidation to form a mixture of carboxylic acids having lesser number of carbon atoms. See, because of that in aldehydes I would add same number everywhere. Carbon atoms. Okay. All right. So I'll do some example. See here. I have taken here acetone and I have done the oxidation with either concentrated HNO3 or KMNO4 K2Cr2O7 in sulfuric acid, and we have boiled it. See here, this molecule will break down here. This portion will oxidize, this portion will be oxidized. Okay, so what will happen? Oxidation of this one, you will get first you will write this one, this, and let me write here this. Only this carbon. Oxidation means removal of hydrogen or addition of oxygen. In this case, what is going to happen? It will be OH. And what will happen to this one? It will be, first I'll write this, and so you get a mixture of acetic acid and formic acid. Okay? Acetic acid and formic acid. See dear, this formic acid, if you look from this side, is carboxylic group. If I look from this side, it is the aldehyde group. We know aldehyde get immediately oxidized. So, in that case, what will happen? Again, this molecule will undergo oxidation. To give you what? To give you, okay, I'll write and rub it. You know, this oxygen will be added here. What you get? Have you seen this molecule earlier? Huh? Yes, you've seen it. This is carbonic acid. See, very interesting. From organic acid, it has become inorganic acid. But carbonic acid is highly unstable. It breaks down to give you water and carbon dioxide. See, when you forcefully pass oxygen through, carbon dioxide through water, it gives you carbonic acid. Moment to open the bottle of the soft drinks, you find so much amount of the carbon dioxide comes out. Why? Because in water, carbonic acid is there under pressure. Remove it, breaks down to give you water and carbon dioxide. What is going to give you? This will not be oxidized. This will be oxidized. So it will give you H2O, CO2, and this will again be here. The ultimate product is this. Okay, this is the one. Now, this is a symmetrical ketone. Both sides is same. But suppose I have taken an unsymmetrical ketone. What is the name of this one? 1, 2, 3, 4, 5. Pentane. Second carbon, you have carbonyl group. So it will be pentan 2, 4. See, in this case, bond can break here and bond can break here. Whatever the bond breaks, it is same only. But in this case, it is not like this. If it breaks here, then this carbon will be oxidized and this carbon will be oxidized. If it breaks here, this will be oxidized and this will be oxidized. Then you are supposed to get 4 carboxylic acid, but actually it does not happen. In case of unsymmetrical ketone, this smaller alkyl group remains with the carbonyl group. Just like that in your house, if anyone, the youngest one, always try to remain with mother. So in this case, when you carry out this oxidation, okay, with, say I have taken here KMnO4, H2SO4, and boil. What will happen? The bond will not break here, it will break here. So this will be oxidized and this will be oxidized. So what should I write now here? CH3, C, O, H, and it will be CH3, CH2. CH3, CH2. This will be oxidized. You will get here this. So what you get here now? You will get here now acetic acid, and here you will get propionic acid. So this is that is a rule. We can say in case of unsymmetrical ketone, the smaller alkyl group remains with the carbonyl group, and the rule name is called Popov's rule. In case of unsymmetrical ketones, the smaller alkyl groups remain with the carbonyl carbon. What is the name of this rule? is called pop-ups. Okay. Now we'll go for the oxidation of tertiary alcohol. This I am taking only for your entrance exam because this is not in your book. Okay. Oxidation of tertiary alcohols. Oxidation of tertiary alcohols do not take place under ordinary conditions. Yes, because the carbon bearing the OH group does not contain any hydrogen atom. Example, see here. See, this does not have any hydrogen. But we can write. However, under drastic condition, oxidation occurs to form a mixture of ketone and carboxylic acid. Okay? So let me take an example. And because it's not in your book, I will not give more examples. Say I have taken here this. See, and write like this. So when you carry out oxidation, it is KMnO4, H2SO4, boil. What will happen? This one will go. So it will get here CH3, CH3, double bond. First it will form this. Okay. I told you the strong oxidizing agent oxidizes double bond also. So what is going to happen? It is going to form corresponding alkene, but these are not stable. So when again this oxidation occurs with KMnO4, H2SO4, because you are continuously boiling it, this will be oxidized. Okay. So what you will get here now? You will get here now this, and this will be oxidized to what? Formic acid. And you know, formic acid will oxidize to give you what? Water and carbon dioxide. Very important for entrance exam. Okay, because I found in Meghalaya everybody wants to become a doctor. I don't know where from you'll get patients. If everyone becomes doctor, then there will not be any patient. Okay. Now, suppose I have taken this. You have taken this. Okay, I'll write directly now. What is going to happen now? See, this carbon will give you Ac2. I'm not going to write this. Okay, I'll write because I don't know. I should not say I feel pity. This word is very bad. But you'll get this one. Again, oxidation will occur. See, this will break here. Sorry, dear. It will break here. So what you will get now here? You get here acetone, and this will be oxidized to carboxylic. So how many carbon are? So CH3, CH2, COH. Well, this strictly for your temperature. So I have finished the oxidation reaction. Clear? Now, I'm going to do a reaction now because of the entire group. Entire. So in that case, we'll go for a very important one, extremely important for your MBOS, I'm telling you. Often it's being asked, is the dehydrogenation. See, what is the difference between, we know loss of hydrogen is called oxidation. Okay. Dehydrogenation is also loss of hydrogen. Then what is the difference between oxidation and dehydrogenation? In oxidation reaction, hydrogen goes out in the form of water. See, all the cases I have written water. And dehydrogenation means hydrogen will go as hydrogen molecule. So now we'll go for dehydrogenation of alcohols. Dehydrogenation of alcohols. So we'll write. Right. When vapors of primary and secondary alcohols are passed over hot copper, in a book the copper is given. Please remember, this is also there. Or silver at 573 Kelvin undergo dehydrogenation, means loss of hydrogen, to form corresponding aldehydes and ketones respectively. Okay. So suppose I have taken primary alcohol HOH, copper or silver, 573 Kelvin. So what is going to happen? At such high temperature, this will go. So what you will get now here? R C double bond H plus H2. So if I have taken ethanol, what is going to happen now? See, this is the industrial preparation because your cost is very less. At least you can use it for a long time. Only thing that you require ethanol. So what you will get now? This, and hydrogen will escape. See, in short time you can get huge amount of aldehyde. So this is ethanol, and this is common name is acetaldehyde, and IUPAC name is ethanol. So any primary alcohol will give you corresponding aldehydes. So this for primary alcohol. Okay, I'll write here primary. Okay, this is also primary. Now if I go for secondary alcohol, suppose I have taken this, okay. Similarly, I pass it over copper or silver. So it is 573 Kelvin. What is going to happen? This. So you are going to get a ketone. You get here ketone. Oh, here I have to write aldehyde. Okay, and you will get here ketone. So if I have taken now isopropyl alcohol, oh, this is second. Isopropyl alcohol, say it is this. What is going to happen? See, it will give you copper or silver 573 Kelvin. So what you are going to get here? See. So huge amount of acetone you can prepare in the lab. So in the industry. Why? Because this acetone is very, very important organic solvents. Okay. Now let us go for tertiary. When you go for tertiary, there is no hydrogen here. So in that case, the product will be different. All right. So I'll write. Tertiary alcohols do not have alpha hydrogen. I'm again telling you what is alpha. It is a carbon which contains the functional group. Okay. So see here. In case of this alcohol, this carbon contains the functional group. But if you have taken acetaldehyde, this is the whole functional group. So the next carbon is what? This functional group is bonded to this carbon. So this is called alpha. Please do not forget. Tertiary alcohols do not have alpha hydrogen. So it undergoes dehydration to form corresponding alkene. Not undergoes, alkenes. So it is, I'll draw it like CH3, CH2H, CH3 na? OH, CH3. What is this? This is tertiary butyl alcohol. So copper or silver 573 Kelvin. See here. Water goes out. So what you are going to get here? CH3, CH3, CH, and water. So you get an alkene. Okay. What is the name of this alkene? It is 2-methyl prop 1, or we call it isobutylene. Okay. Isobutyl 1, 2, 3, 4. Butyl. Okay. So with this chemical properties I finished. So that day I told you how to distinguish primary, secondary, and tertiary alcohols. In the distinction process, we use Lucas reagent. Okay, we use Lucas reagent. What is Lucas reagent? Lucas reagent is a mixture of concentrated hydrochloric acid and anhydrous zinc chloride. So, if it is a tertiary alcohol, it will give you immediate turbidity or cloudiness. Secondary alcohol gives turbidity after 5 minutes. And tertiary primary alcohols do not produce any turbidity at room temperature. Okay, so this test is known as Lucas test. Now, one more test is there. That is not in your book, but I'm doing only for entrance exam. It is called Victor-Mears test. I'll write down the whole sequence of reaction, okay, and you can see this one. Victor-Mears test. Victor-Mears test. Okay, I'll write down here. Primary alcohol. Primary alcohols. Okay, I'll write down here. R C H. Wow, background music is also there. Very nice. Huh? Good. Yeah, then in that case you will not get bored. From tomorrow onwards, I will play background music. You tell me what song I should play. Okay. See here. This will react with hydrogen iodide or with phosphorus Pi3. How to generate Pi3? I told you phosphorus, red phosphorus, and iodine. So what you will get now? You will get here I. Then this one I will treat it with silver nitride. This also we have discussed in haloalkanes because nitride is a embedded in nucleophile, and if it is silver, it will bind to nitrogen. You will get this. Now, this one will be treated with nitrous acid. How do you generate nitric acid? Sodium nitrite and HCl. So what is going to get? You will come to get here. You will find. You will get here. This. We call this one to be nitrolic acid. So all this name you need not remember, okay? Because you are too young to remember all these things. Only I told you are all Cerelac babies. Only by volume you have increased. Now, to that I will add sodium hydroxide or potassium hydroxide solution. Moment you add this one, you are going to get blood red color solution. Blood red solution. So I think you know what is the color of the blood, otherwise you can cut your finger right now and you check. Now we'll go for secondary alcohols. Okay, we'll do the same way. So right now here R, H, OH, say R1, R. So same thing we'll do. Reaction with hydrogen iodide or PI3. How do you generate PI3? They're all intelligent people. You can do it by this way. So you will get here R1, C, H, I, R2. Then what you will get? Silver nitrite. Mind it, not silver nitrate. So you get here you will get. Then it will be treated with nitrous acid. Okay? How do you generate nitric acid? Sodium nitrite plus HCl. Okay? So what you are going to get now here? R1, R2, then NO2, and here will be only NO. Okay? This name, this type of name so you cannot remember. We call it pseudo. Pseudo. Yeah, I think spelling is wrong. No? Oh, yeah. PSEUDO. Pseudonitrile. Okay. Then similarly, we'll add here sodium hydroxide or potassium hydroxide solution. You will get here blue solution. Then we'll go for tertiary. In tertiary, alcohols. Okay. Now what is this tertiary? R1, R2, R3, OH. So we'll treat it with hydrogen iodide or PI3. How you generate PI3? This is a symbol of red for us. This red phosphorus, P4 and I2. So what you are going to get here? R1, R2, R3. Then we'll add here silver nitrite, AgNO2. What you will get now here? R1C, R2, R3, NO2. Now see, this does not have any hydrogen. It is not going to react with nitrous acid. So, but anyway, we do not know. How do you know? We cannot see the molecule. Okay? Sodium nitrite and HCl. So, what we'll write now? We'll write it does not react. So, even after addition of, but we do not know whether it's reacted or not. We'll add here now sodium hydroxide solution. We'll write here colorless solution. So this is the Victor-Mears test. So many equations you cannot remember. So what you will write? What you want to remember? You will only remember primary alcohol, blood red. Secondary alcohol, blue. And tertiary alcohol is colorless. Only this much you remember. Primary alcohol, blood red. Secondary alcohol, blue. And tertiary alcohol is colorless. Okay. So with this, I finish alcohols. Tomorrow, I will do the phenols. This chapter, I cannot go fast. Okay. Alcohol, phenol ethers, and aldehyde ketone carboxylic acids. In your board exam, number of mark may not be that much high, but this year is because, see, this year is because 2 chapters are being removed. like the chemistry in everyday life and the polymer. Mark though they did not remove. So now you will find more questions from alcohol phenol ethers and the acid aldehyde ketone and carboxylic acids. So you have to be a little more careful. And I want that you should get full marks. All the reactions which is there in the book, one by one I have discussed, along with all probable questions which you will get in the entrance exam. Okay? Thank you. And
Thank
good
you,
day.
sir. Good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome, dear. Welcome.
Layak deh. Demi Ustaz.